Hello, hello. All right, here we go. It took a little while to get started, but all right, everyone. So we're down to chapter 9, which is on polar coordinates. Polar coordinates is basically a way to plot a point based on not what we're so used to. We're so used to plotting with an x and a y coordinate, but now that we know a lot about angles and unit circles and degrees and so forth, we can actually now graph using what we call polar coordinates. And what it is this. Like in this example, you'll see a polar coordinate. The first number you see is actually the radius length of basically the radius length of a circle, of a circular movement that you're going to perform. And the second one is the number of degrees or the number of radians. It's basically the angle. It's either going to be degrees or radian. That's how many degrees you're going to go around or circulate around in that circle. So for example, it's not actually that difficult. Now I went ahead and prepared this ahead of time. Typically you'll just have an X and Y axis, basically what you're used to seeing, an X and Y axis. But this axis is actually a little different. So what's going to happen is, like, let's call this a circle of radius 1 unit. If we go 2 units and draw the circle, that's a circle with a radius of 2 units. This next one is a radius of 3 units, so there's your circle with a radius 3. So what's going to happen is we're actually going to plot a point not so much on what we're used to seeing, which is a rectangular coordinate. We used to call them rectangular coordinates. Let me take you to this side here. A rectangular coordinate is when you go, like, let's say 2 units to the right and 3 units up. So basically you form some sort of rectangle figure. But here in polar coordinates, we're actually going to plot using circular movement. So let's go ahead and begin. So this is 1, 2, 3. This is 3 units. And we're going to go 4 pi over 3 degrees around the circle, just like we're used to plotting. So we have to figure out how many degrees that is. I know most of us, we didn't get to practice that much in radian this year because our year was kind of cut off short. But I hope you know that this is 180 divided by 3, which is 60 degrees times 4. That's 240 degrees. So if you wish, you can change that to degrees, and maybe it's a little easier to work with. So you're going to go 3 units length in a radius, and then you're going to go 240 degrees around the circle, which would be about this much, right? Because it's 270, so it'd be somewhere around here. It's basically 60 degrees beyond the 180 marker. So again, we went 1, 2, 3 radius length unit, and we're going around the circle 240 degrees, and we're landing right here. And that point right there would be point P. That's how we plot a point using polar coordinates. So it's not really that bad. We're just combining things that we already know. Now there's going to be different little things that we kind of hatch out along the way. For example, let's go to the next figure here. Example 1b. By the way, we're done. We plotted the point. All right, this one says negative 3.5. Now with rectangular coordinates, negative 3.5 would mean to go to the left. But actually here, we're saying the following. We're saying go to a radius that's 3.5 units long, so 1, 2, 3.5 right here, and then go 150 degrees, so that's 90, 150 would be about here, about 30 degrees away, right there. But wait a minute, this was a negative, which would basically be like a reflection. It's a reflection across the origin, so this one would actually go over here, 30 degrees this way. It was 1, 2, 3.5 right here. 30 degrees would be right there. So it would not be that one. Let me exit out here. It would not be that one. It would actually be this one right here. This right here would be your point Q. Point Q is right there. Because again, we went 1, 2, 3.5. We took 150 degrees here. But because the negative was in front, the negative actually means to reflect it across the origin, and we actually end up over here. So a negative doesn't mean to start on the left. It means since the radius is only positive, you're going to go 3.5 units long in the radius. You go so many degrees, but at the end, this negative is actually just means reflected across the origin, okay? All right, so we're going to go to this one here. Let's go to the next one. I'll use green for this one. We're going to go 2 units. So again, remember I pre-planned these ahead of time, so I made my circles ahead of time. So this is a radius of 2, and going negative pi over 6, which is, again, well, let me write this. In degrees, that would be 180 divided by 6, which is 30 degrees. So you're going 2 units this way, and then 30 degrees to the bottom. Now, please don't get these confused. That's it, 30 degrees. There's your R. So you're just going 30 degrees away from this marker right here, 30 degrees away. So again, don't get confused by this. I'm going to go ahead and do this. Look, for this one, just so you can see. So basically, we went 30 degrees to the bottom. This is a 2 radius length, or 2 unit length radius, but it went 30 degrees to the bottom from or into the 4th quadrant. So a negative angle still is like before. Remember, positive angles go into the 1st quadrant and go counterclockwise. Negative angles go into the 4th quadrant and go clockwise this way. So this negative doesn't change anything from what we've learned. The only thing that's different is a negative here. It means a reflection. Okay, that's pretty much it. I mean, that is the main thing about polar coordinates. Again, we're not going to get very deep into these topics only because we didn't get to see this in class. So this is just a quick getting our feet wet with polar coordinates and what they are and so forth. All right, let's do this. What if I give you polar coordinates, and you can recognize a polar coordinate because they start off with a number, and then this one will either be some sort of degree or some sort of radian measure. So this is a polar coordinate. I want you to give me the rectangular coordinates of this point M. So what that means is, if you go 4 units, like 1, 2, 3, 4, 4 units, right? If the radius is 4 units long, and you go pi over 6, which is 30 degrees high. So if it's this, and you go up here, you'll end up with this point being in this position right here. Again, you went 4 this way, and then you rotated it so you land over here. So at that point, what you have is the radius is 4 units long. Remember, the radius was 4, but it went this way. So now what I'm looking for is the x and y values. So let's think of it this way. This is radius 4, and I am going to need the y coordinate right here and the x coordinate right here. Remember that we did go 30 degrees from here. So it's a 30, 60, 90 triangle. Now, at this point, to find x and y, you can either use sine, cosine, tangent, or the 30, 60, 90 properties, or the 45, 45, 90 properties. Whatever is quicker and better for you. Now, if you use 30, 60, 90 properties, is actually better, and 45, 45, 90 properties whenever they come about, because those are going to be nice, perfect numbers, no decimals. But again, either way, it's correct. So for example, if you recognize this is a 30, 60, 90 triangle, simple as 1, 2 square root of 3. The hypotenuse is twice as big as the short leg, so this is 2 right here. If you don't do it that way, you're going to set it up as the sine of 30 equals y over 4. You do the math and you're going to get 2 right there. If this is 2 and this is 4, this is 2 radical 3. 2 times 1, 2 times 2, 2 times square root of 3. I use the 30, 60, 90 properties, but remember, if you're having issues with that, you can use the sine to find y and the cosine to the same x. You'll get the same answers, but in decimal for this one. This would be, let's see, the square root of 3 is 1.7. This would be about 3.4 units long if you did it using the cosine. Just to speed up the process, I use 30, 60, 90 properties. All right, I'm ready to give the rectangular coordinates. I'm going to give it in perfect value here. So it's 2 radical 3 to the right, and then 2 units up. And this right here is my rectangle, or my rectangular coordinates. In other words, x and y, back to x and y. To plot this point right here, I would have to go 2 radical 3, which is, again, about 3.4. Let me get the calculator here. 2 square root of 3, just to make sure, 3.46. Okay, so more like let's go 464, and then 2. Like, you would have to go 3.4 units this way, and then 2 units up to land right there. Okay, that's rectangular coordinates. This is my answer, or this one in decimal. but it's still the same thing. All right, let's do this one. All right, remember that this is a polar coordinate. If you go 2 units this way, if the radius is 2, and then you go 135 degrees, which would be right here, but there's a negative, which means you reflected it, so you end up going over here. All right, so you're going 2 units, you're going here, you're going here, right there. So once again, what you have in essence is a radius of 2 right here. Let me redraw this let me draw it over here. A little bigger, let's focus in. So you have a 45 degree angle here, and you have a 2 radius length. This is the radius right here, 2. Remember, you start with 2 and then you went around this way. You went around this way and then flipped it over, so it's over here. So it's a 45 degree. It's a 45, 45, 90 triangle. So this other side is 2 divided by the square root of 2. 2 divided by the square root of 2. Or you can use the sine, cosine, or tangent. You can use the sine, inverse sine or inverse cosine, and you'll get these two sides. Either way, you'll get decimals, which is 1.414. If you clean it up, that's actually, if you multiply by the square root of 2, you get 2 radical 2 over 2, which the 2's cancel, so that's the square root of 2. So the best answer is actually that you're going square root of 2 this way and square root of 2 this way. So my x-coordinate is the square root of 2. I have to go the square root of 2 units this way and then the square root of 2 units this way, so negative square root of 2. To land at that position right here, to land in this position, again, the square root of 2 is about 1.414. So you would go 1.414 this way and 1.414 this way, negative 1.414 downward. So this is in decimal, this is in radical, but it's the same thing. And I used the 45, 45, 90 properties, but remember, you could also use the sine and the cosine to figure out these answers as well. Okay, moving on to the next thing. Let's find the polar coordinates given rectangular coordinates. So if you started with these, if you went 1 this way and radical 3 this way, well, let's make it a little bigger. Let's say right here, if you went 1 this way and radical 3 this way, what would be your polar coordinate? You have your rectangular already. Just trying this thing here. Okay, so how many degrees would this be? So you can use the inverse tangent. Now, I recognize something. I think this looks like a 1, 2 radical 3. But let's say you didn't know what this theta was. Opposite, adjacent. Since I would be giving you the opposite and adjacent, you could do the inverse tangent of the square root of 3 over 1, which is the square root of 3, and you would see that you would get a 60-degree angle. Again, if you type, you can use the calculator, but if not, this is basically, it's a 30, 60, 90 triangle where this is 1, this is 2, and that's a square root of 3. So this is a 60-degree angle. This is the 30-degree, but that's a 60-degree angle right there. But by doing this, you get 60 degrees. So see, we need that because in polar coordinates, remember, you need the radius length, you need the radius right here, and you need the degree measure or the angle right here. The radian or the degree measure, either one. I think we're more familiar with the degrees, so I'm going to use degrees. So we have part of our answer already. I know this is 60 degrees over here. Let me go ahead and erase that. So I know we have 60 degrees over here, if I can get this thing to right. 60 degrees. What I'm missing is the radius length. But again, if you know your properties, that this is 1, 2, square root of 3, the radius is just 2. If not, you can use sine, cosine, or tangent to find the missing piece, and you're going to get 2 as the radius length. The radius is the hypotenuse right here. So there you go. It's as simple as that. This is my polar coordinate given this rectangular coordinate. Now let's do this one over here. Negative 3, 6. Negative 3, 6. Oh, by the way, in your assignment, the bonus point assignment, I may ask you to do this, like to identify this answer, the polar coordinate, 2 different ways. Well, another way you could give the answer is, all right, how about if we go 60 degrees over, 60 degrees over here, which means 90 plus 60, 150. or 180 take away, let's see, 60 right here. Actually, it's going to be 180 take away 60, it'd be 120 right here. So a 120 degree angle, which would be the same 60 degree reference angle, 120 degrees. So if you go 120 degrees, so you have a radius of 2, you go 120 degrees, well, that would land you over here. But then if you want to land back in this position, you just make that negative. This would actually be a different way. It's the same as this one. It's describing the same position two different ways. You could also do the following. Let me go in green. If you want a different way to do this, and by the way, I forgot to put the little parentheses there. If you want to go a different way, then what you can do is say, all right, I'm going to go radius length 2, and I'm just going to go 60 degrees to the bottom, so negative 60 degrees. And of course you can also go, and that 60 degrees looks a little weird here, so let me clean it up a little bit. So it's 60 degrees there. All right, so these are 3 different ways of naming the same exact point, landing in the same exact position. And remember that you can always go radian as well, but it's not a different way. It's just 180 divided by 3 is 60, right? So all of these are different ways of saying the same thing. This one and this one, and all of these describe the same 1 negative radical 3 position of this point right here. So again, just be aware of that. So I just wanted to share that with you. All right, let's do this one right here. Negative 3, positive 6 will land over here. So if you went negative 3 this way and 6 this way, then, and again, my picture is not to scale, but then you're having this here. So this is 3 units here. This is 6 units there. I'll label like that. Once again, we're going to need the radius length, and we're going to need the theta right here. So you can start by using the inverse tangent of opposite over adjacent, which again you'll have basically 2, the inverse tangent of 2, and you get 63. So this is about 63 degrees here, 63 degrees. We'll go with the nearest degree there, 63. So basically you're going to say 180 minus 63, that's 117 degrees. So you're going to go a certain number of units, that's the radius, and you're going to go 117 degrees over to land at that position. Okay, so again, I just need to know now the radius, which you can do the Pythagorean theorem. Remember, the Pythagorean theorem would say that, let me go green here, the square root of a squared plus b squared. That's 9, that's 36, that's 45. So this right here is the square root of 45. You can clean it up as 3 radical 5, I believe, but if not, you can leave it like that. We can even actually put it in decimals. So this would be the square root of 45 units long and 117 degrees rotation. So it's so many units long and 117 degrees this way. That's going to land me right there. So that right there would be the answer. Remember that you can use decimals. So if you did the square root of 45, I believe you get 6. I'll just go to the 10th place, 6.7 and then 117. Of course, this is not an exact answer, but it's an approximation. Square root of 45 is about 6.7 units long. All right, guys, well, that's pretty much it. Let's see if you can figure out my bonus questions. Good luck on that.